Alright, hello and welcome. Today we're going to be looking at the trigonometric ratios, and you should be somewhat familiar with some of these from Year 9 and Year 10. We are going to extend on these a little bit today. Your teacher may have shown them to you in Year 10, but we'll see how we go. So let's start with the basics. The trigonometric ratios, you should know these already. You should know for a right-angled triangle, if you have some theta here, you can label your sides. This is the hypotenuse. This is the opposite. And this will be the adjacent here. You should know the first three trig ratios, those of sine, cosine, and tangent, or sine, cosine, tan. And for those ones, we have sine theta is opposite over hypotenuse. We have cos theta is adjacent over hypotenuse. And we have tan theta is opposite over adjacent. And I hope you're pretty familiar with these, familiar with how to use them as well to get yourself some answers, solve questions. So just a quick overview of what these are useful for. Any sine, cosine, tan, any trig ratio is linking an angle and two sides. So we've got theta here, and depending on the sides, depending on our question, we've got the opposite, the adjacent, and the hypotenuse. So these are all well and good. These should be familiar. I shouldn't have to go through much of these with you. If you do need more help on these, I would certainly recommend doing some questions, looking back over YouTube, finding some other good resources. Now, from here, we do add three different ratios. So opposite over hypotenuse, that's all well and good, but what about if I want the other way around, hypotenuse over opposite? And I can solve questions like that if I've got unknowns on top or bottom, so we can manipulate around a little bit, but there are also formal trig ratios we need to learn, partly because it will help us solve different bits and pieces, it will help us with some identities and some proving, and partly because later on it will help us with our development of calculus, especially on the trig functions. Okay, well, what are those functions? Well, next we have cosecant, or cosec, and cosec theta is, it's going to be hypotenuse over opposite. So it's the same as the sine ratio here, just upside down. Next we have sec, or secant. Sec theta is hypotenuse over adjacent. And we also have cot, and cot cotangent theta is going to be the adjacent over the opposite. Okay, so these three here are all new. You'll need to learn those. Now, obviously more things to remember. I mean, trig already has three ratios, and I get that can be confusing. If you're doing extension 1, there's a whole freight train of things coming your way. But just to memorize these, well, for the first three ratios here, we had SOHCAHTOA, and that was nice. And you'll probably be relieved to know there is a simple-ish way of memorizing the three new ratios. But we'll get to that in a minute. Actually, no, we won't. Let's go on now. So, given sine, cos, and tan here, I think it's not going to be a massive extension for you if you can see that this here is 1 over sine theta. Okay, so it's the same as sine theta upside down. So if you flip that, you get cosec theta. This here is 1 over cos, and cot is 1 over tan. Sometimes known as the reciprocal ratios. In terms of memorizing these, getting them all out, cosec, look at the third letter. So third letter there is S, right? S matches the sine there. So cosec is 1 on sine. Sec, third letter there is C, is 1 on cos. And cot, third letter there is 1 on tan. Okay, so cosec, 1 on sine, sec, 1 on cos, cot, 1 on tan, and in each case, opposite over adjacent has been flipped, adjacent over opposite, adjacent hypotenuse, hypotenuse adjacent, same at the top. So we're just flipping both sides, or flipping top and bottom. Okay. Now, like I said, these will help us later on. They also can help us just in development of complements as well. So you may have noticed, just getting a little bit more technical, that 3 of the ratios have this co-business going on. So cosec, cos here, and cot here. So cosec was cosecant is the full name for it. Cosecant, this is secant here. So secant and cosecant have this property of being complementary. Okay, so being complementary means, in a sense, they add to 90 degrees. So you can actually say that cosec of theta is the same as sec 90 minus theta. Or you can say that backwards as well, and you can say that cosec 90 minus theta is the same as sec theta. Okay, and that's because of this co-property. Okay, cosecant, secant, cosecant, secant. You see it again over here. You have sine here and cos here. Cos is cosine. So sine and cosine, they go together as well. They have similar properties like what you see here. Okay, so if you are looking at those two, you can say that cos theta is the same as sine 90 minus theta. Or alternatively, that cos 90 minus theta is the same as sine theta. Okay, just the complement in there. And lastly, with tan, tangent. So tan does stand for tangent, and cotangent here, same properties apply. Okay, so yes, there's quite a bit more to remember, but you can simplify it down a little bit. Okay, so sine, cosine, tan, you know those three, SOHCAHTOA. The reciprocal ratios, cosec, sec, and cot. 1 on sine, the third letter, 1 on cos, the third letter, 1 on tan, the third letter as well. I might grab a different video to do some examples. I'll make sure I've got those written down. If you have any questions, I'd say go do some exploring. Thanks for watching.